Hi, good morning. Today is December 11th, 2025, and it is 10:15 a.m. U.S. Central Time. My name is Rinaldo J. Aguiar Marcano, and I am recording this video from my home located at the 2302 Britton Ridge Drive, Katy, Texas 77494. And this home is located about 300 feet away from the home of a gentleman by the name of Robert Mueller, who was the director of the FBI for several years, some years ago. And although that sounds like a random comment, that is very relevant to this conversation. Um, and both of our houses are located in Lake Point Estates, which is a gated community, a subdivision really. It functions like a small city that is managed by a person by the name of Philippe Denning. He is the president of the Homeowners Association, quote unquote. I say quote unquote because most of the houses are really owned by the Communist Party of China. But I digress. So today I'm very excited to talk to you because I would like to do. So today I'm going to do something a little bit different. Okay. What I'm thinking is to do kind of a code lab. Okay, a code lab for people that are not software engineers, but don't get intimidated by the name. Right, like it's going to be easy to follow. But in software engineering, a code lab is basically it's like I don't know if you remember when you went to high school, right? That you would go to science class and there would be like a I don't know in Spanish. My school was in Spanish. I don't know the translation in English, but we used to call it lab, like the laboratory, right? And like the science lab, and you do these experiments that were pre-designed, right? Like somebody thought beforehand how to do the experiment, right? And it was standardized, and everybody did the same experiment. It's the same idea, but with software, right? Instead of dissecting animals and stuff. Um, but in this case, it's not so much about the software, but about the network, right? So the code lab is about how to debug a specific part of the network, right? That is doing all this using a couple of things. One is technology, open source technologies, and Google Cloud, right? Is what I'm going to use mostly. And also the data from the Elon Musk GeoIndex that Diosdado Cabello handed to me on September 2024. So with those things, and public records, that's the other thing I'm gonna use. So with those things, the idea is to debug a few things, but I want to do it in a way that it's end to end, right? So I mean, in reality, a code lab would be something that is pre-designed, that somebody prepared and tested, but I did not do that, right? So what I mean is that I thought about how I would debug this thing, right? But I did not really do it. The reason why I did not pre-design the experiment is because the same thing I mentioned in the previous demo, right? Like I want to face the obstacles that you will face, and I will try to solve them on the fly here, right in front of you. So I think that makes a more educational experience because if I get stuck, you will see me getting stuck, and hopefully, right, if things go, my way, I will be able to get unstuck somehow, right? I don't know what's going to happen, but of course, the risk of this is that I may get stuck and not be able to get out of it, right, in a reasonable amount of time, and then the demo will not be very good. But hopefully that will not. I will make my best effort so that doesn't happen. But if it does happen, you'll have to excuse me, right? I mean, there could be unforeseeable situations, right? But I intentionally did not test this, and I did not debug it because also I don't want, how do I say this? I would like to be able to not have any bias when I see these things here in front of you, right? So in this process, I mean, it's possible that we debug this and we find nothing, right? Like there's nothing really here to see. But it's also possible that we find things. I want to tell you that if we do find things in this debugging session, I want to tell you that these are not things that I have seen before. Like I did not debug this beforehand. So anything we find, we are finding it here real time, right? Um, and what usually happens, and, because at this point I know my you know my mode of operation. So what usually happens is, I mean, if we find something or a few things, what will happen to me is that there might be things that I will not be able to understand right away, right? But tomorrow or in a couple of days, after things simmer in my head, I may be able to realize certain things that I miss here, right? So that, I mean, that it could happen, right? Um, so that's the game plan, okay? And for this, I'm going to take it all the way. So from the very beginning, right? So from scratch. So I'm going to set up everything from scratch. And the goal of my goal by doing that is to give you something that is repeatable, right? Um, I mean, well, whoever will watch this video, right? To give something that you can repeat and you can modify and adapt to different countries, different, even in the US, different states, different, or even internationally, right? I mean, I want to give you more a framework than a solution, because a framework can scale globally, right? And that's the end goal is to scale this globally. Because the problem is a global problem, right? What they're doing is global, so the solution needs to be global. Um, so that's my goal. So I'm gonna take it from scratch, from nothing to very high level, meaning I'm going to build dashboards at the end, right? So something very graphical, very visual, that you can dissect and play with. And then at the end, after when I post this video, I'm going to put in the description of this video, I'm going to put the link of that dashboard, so you can see the end result even before you decide to watch or not watch this Codelab, right? So my goal here really is to do something end to end, okay? But as I said, because I did not prepare this and I did not debug this beforehand, the price that we have to pay for this, let's call it experience, is that it's going to be a bit bumpy, right? I may get stuck in certain places, or it may take longer for me to set up something because I did not set it in advance, right? I did not set it up in advance. So there is a small price to pay, right, for that. Which is that this demo might be longer and a bit boring if I get stuck, right? But I think the reward is worth it. So before I jump into that, I want to just mention a couple of small items. Let me start by sharing my window with you, my calendar with you. So there's been a couple of things that have happened. I mean, after I did the last two demos, and I just want to mention them here in case, I mean, these are kind of observational things, right, that I've noticed. And I don't know, right? I don't know the answer to this. Give me a second to find something here. What is it? Okay. One second. Okay. Okay, so the first thing I'm going to show you is if you go to texascourts.gov, and this I just noted this morning. But if you go to the first appellate court and you do a case search, and you search for this particular case, which is the last, no, this is not this one. It's not this one. Give me just a second, I'll find it. Okay, it's this one. I'll give you the case number. It's 01-25-00978-CV. So if you look at that case, today is December 11th, right? As I said at the beginning. So yesterday, December the 10th, there was an event enter into this case that says motion for rehearing due. Okay, so this sounds. I mean, I haven't run this through the legal pipeline, and I will do that, right, to figure out exactly what this means. But it sounds odd to me for two reasons. One, the case is closed. Like they dismissed this case procedurally on 11/25th. The same day that I filed, after they did that, I filed a petition with the Supreme Court of Texas. So this case is closed, right? It's dismissed. So why are they filing a motion for a rehearing? The second thing that is strange is that the word rehearing implies that there was a hearing, and this is not true. This case was never heard. There was no hearing. They dismissed it procedurally, citing want of jurisdiction, right? So they said, we don't have jurisdiction over Judge Brown. But now they're saying that there is a motion for a rehearing due. How can there be a rehearing if there was not a hearing in the first place? I don't know. It sounds odd, right? And the case is closed, so why is this appearing here? So I don't know. It could be a procedural thing related to the Supreme Court case being filed, but it sounds strange, right? So it could be that it's a way to introduce something into the docket that makes it sound like there was a hearing. And that could be because I've been making these claims in federal court that they have systematically denied me a hearing in all the courts, right? There hasn't been a court in Texas, a state court, in which I've had a hearing. Not even in federal court. In federal court, I also haven't had a chance to have one hearing, right? So because I'm making these claims, then I think that could be why this appeared in the docket conveniently yesterday, right? December 10th. So that's one observation. I emailed a lady by the name Noemi Hernandez, who is the clerk of the First Appellate Court, and I have her email because she emailed me a long time ago when I filed the first petition, right, with that court. So I have the email and I have the name. So I emailed her asking her what does this, if she could, guide me on what does this mean, because I'm a pro se litigant and I don't know exactly if something is suspected of me because this entry appeared magically in this dismissed case, right? So I asked the question, but I haven't, because I'm doing that was like half an hour ago, right? So after this, I'll check, and I will run this through the pipeline to see if there's anything that I need to do, or this is a unusual procedure, right? Or unusual. Either way, I need to learn, right? Because it has different implications. So that's one thing. The second thing is I've been filing documents in the federal court for the last 2 days. They're small things, right? But something interesting happened. I noticed that in the 2 days, so Tuesday and Wednesday, right? I went on those 2 consecutive days to the federal court. In the 2 occasions, there has always been a clerk that is now wearing blue gloves. And as I mentioned in the previous demo, during the last 8 months, I've never seen this before, until that day when they, didn't really file the document in full, until I went there, right? But now, the last 2 times I've gone there, there's other clerks, not the same lady, but different other clerks, and they're wearing the blue gloves. So it could be that the head of that department, what is his name again? I have it here somewhere. His name is Nathan Ochsner, right? It's possible that Mr. Ochsner, maybe after that demo, right, when I talked about the blue gloves, maybe he implemented that as a departmental policy, right? Because that would make it look like it wasn't a deliberate attempt to hide the fingerprints. It's possible, I don't know, right? But I want to note that I haven't seen this before. I saw the first time that day that the document was not really filed, and I described this in a previous demo. And now, after I said that in a demo, every time I go to the court, there is somebody wearing blue gloves. So it's strange. And the other thing that happened was that yesterday, I had a conversation, which of course got transcribed and ingested in the pipeline and processed, and it got flagged. It was a conversation with my former partner in which she was, I don't want to drag personal stuff into these demos. But to make the story very short, she was saying that I was a very bad person because I was making her spend more money in legal fees because I didn't want to leave Morgan. The translation would be, it was in Spanish, right? But because I didn't want to let Morgan Heibner leave the case. So she was obligated to pay her more. And that she now had to retain another lawyer for the Supreme Court case. And all these got flagged for multiple reasons, right? And I'm not going to get into details, but like, it is not, I mean, Morgan Heimner can be in the case and not do anything. Like there's no billable hours if she doesn't file any documents, right? And she is not going to file any documents because there's Troy Pickett. So there's no reason for the billable amount, the number of billable hours to increase, right? Even if she stays in that docket for a year because she is not doing any work, there's no reason for the cost to increase, right? Also, the comment about hiring a new attorney for the Supreme Court case, that is also, I know that, obviously, because, it got flagged in the sense that I said in multiple demos before that they cannot have a hearing with me for obvious reasons, right? So they're not going to bring another lawyer into this mess, because that lawyer will have to examine the documents and see the fraud, right? And so if that lawyer sees, the level of fraud and confessions that are really at play here, it would be a very tough choice for that lawyer, right? Like they will have to choose between reporting them to the FBI or the authorities, or being complicit on this. But the conversation was mixed with something about money, right? Like she was complaining that she was running out of money. So it could be a way to justify that she's still going to retain a lawyer to explain, right, why Troy Pickett was retained for the First Appellate Court, but there is not an equivalent to Troy Pickett in the Supreme Court, because there's not, right? Like, and Troy Pickett cannot say a word, because if he says a word, he will incriminate himself further. And the same with Morgan Heimner. So they're listed in the Supreme Court case, but they cannot really file anything, right? Because they would incriminate themselves. So I don't know. It's just a super tricky situation. But the comments seem designed to justify, whatever it is that they're going to do, right, or not do, right? Because either way, it's going to raise questions. But anyhow, I just wanted to mention that. Okay. So before we start, let me start by saying that all this, the idea of doing this Codelab came to me because I was doing QA on the last demo that I offered. I was doing QA on it yesterday, and I saw that comment that I made. I said something along the lines of, that the FBI or some agency needs to create, in my opinion, right? This is just my humble opinion. I would contend that somebody needs to create a department to regulate the attorneys, right? Because obviously, if they keep doing, and not if they keep doing this, they've been doing this for a long time, right? But, at this rate, they're going to take over the world. And I'm talking specifically about the attorneys. Because they can take anybody's child with these procedural tricks, right? Or they can medicate somebody with these procedural tricks, or they can commit somebody to a mental institution if they want, right? So it's... I made that comment, right? But when I'm doing QA, I thought, well, maybe people will think that this is an inflammatory comment, like, So I thought, I probably should do something more demonstrative of what I meant, right? Like, I guess what I'm trying to say is that I want to offer that comment not as a rant or as a complaint, but I want to offer you a vision, a possibility, right? Whether people adopt it or not, that's beyond my control. But at least I try, right, to show what I meant. So me doing this for the last few months, for the last 8 months, I'm seeing that there's actually two things that are needed, right? I guess what I'm trying to say, hypothetically, right? I know that I'm not saying that I have that power or that I can make that happen. I know I can't. But think for a second that I had the power to create this department, right? How would I structure it? Is the question I ask myself, right? Well, so I think because of what I've been doing for the last few months, I think I would try to make it so it mimics what I've been doing, because what I've been doing obviously has been successful, right? Uh, I mean, in terms of fencing them off, right? Um, so that made me think, okay, what is that I've been doing? So I've been doing two things, right? One is using technology for detecting, um, procedural tricks and manipulations and things like that. So this requires I mean, I'm doing it with software, right? But if you want to create a team of people to do this, you need people really that have experience doing this work, right? That's what I would think, right? You would need people in this team that have been clerks, that have been attorneys, that have been judges, right? Because they would have seen all these tricks, right? And they would give you ideas that, for example, I don't have those ideas, right? I detect anomalies with software, right? But if you have people that have done the work, right, for years, they will have experience that is invaluable, right, in catching these things. Uh, I guess, right, what I'm trying to say, like, I don't know, sometimes I've seen in the news things like, I don't know, the FBI caught somebody who was counterfeiting currency, right? Like, making fake bills. So, well, they apprehend the person, but they also, if they can, or I don't know, I've read this in the news, right? They take the person as a consultant, right? Like they give them some benefits, but the person helps them because the person has developed a know-how, right? They know how to do it, and if you have somebody who knows how to do it, you can develop the countermeasures, right, or the detection measures. So that's one part of it, right? The detection of the procedural tricks and the manipulations and all that. And the second part is how to detect at scale these operations, right? Like the ones that they have with the Adams law firm and the Troy Pickets, and how do you detect these actors at scale? So this Codelab is more about that second part. How do we detect these actors at scale? Because so far in the previous demos, I've talked a lot about how to use technology to catch the procedural tricks, right? Like the anti-manipulation pipeline, right? Which I have mentioned several times. How I can catch the TTPs of the deceptive title documents using NLP, right? Like all those things are already documented in the demos. But how to catch the operation itself, right? Like how to detect the anomalies in the operation. Not in a single case. So this is one level of aggregation higher, right? So far until now, I've been talking about how to apply technology to the case, right? To the case that I'm working on, my case, right? To recover my parental rights. But in this Codelab, I want to talk about more high level, like how to apply technology to detect anomalies in a series of cases, right? So this led me to think, okay, well, if, in this hypothetical unit, let's call it, right? I don't know, I want to say hypothetically, this would be a unit in the FBI. I mean, I'm just talking about this hypothetical unit that I would, in my mind, right? If I had any saying on that, if I worked for them, or somebody asked my opinion, I would say, I would create this unit, right? So give me just 1 second to file my files over here. Right. So to put in concrete terms, I would hypothetically create that unit in the FBI, for example, and I would call it something, because it's important to give things a name. So I would call it something like Administration of Justice, Deception, and Malfeasance Section, something like that, right? Administration of Justice, Deception, and Malfeasance Section. So the acronym of that will be ADAMS. But that is a pure coincidence. Like, it has nothing to do with the Adams law firm or with the, it's just a coincidence. But I would call this unit Adams, right? So this Codelab is really what would be the workflow of an engineer working for the Adams unit, right? Of the FBI, to catch this kind of operations. That's the idea. Okay. So this is what I did. The idea is, we're gonna pick, for these things, it's usually a good idea. And now this is me talking to you as an engineer that has experience doing this kind of work. Okay. In this thing, there's different ways that you can go about this. Okay. So you could try to do this at planet scale. You can start, like doing this, or a country scale, or I don't know, state scale. high scale, right? But this is usually not desirable because, I mean, to begin with, right? You want to do this as a last step. But at the beginning, you want really to debug in a concentrated area. Think about it as an aggregator. If you focus in one aggregator, you will be able to see anomalies that are visible because you're working on a very constrained set of it could be like a geographical area, or it could be a constrained set of cases, or a constrained set of circumstances, right? But that will allow you to see anomalies. If you do this, if you start doing this from the get-go at very large scale, what will happen is that different systems will introduce different characteristics into the samples or the observations that you are looking at. And that will introduce noise. Like, it's like they will introduce like a canceling effect, right? Like, I don't know, some cases will have certain characteristics coming from one aggregator, but from another aggregator, you could have the opposite characteristic, right? Coming into the sample. And the effect of that, when you combine them, is that you cannot see anything, right? Because it looks like a normal distribution. But if you concentrate on only one aggregator, then you're able to see things that are obvious, right? So with that in mind, what I'm going to do, I'm going to pick one aggregator randomly to work on, okay? So of course the question is, how do I pick that aggregator? So I don't know, so for this session, I'm going to use the AI thing that Google has. So it's called Gemini, right? I'm going to ask questions, right? When I don't know something, I'm going to ask a question here, right? So I'm going to implement here a very random selection algorithm to pick the aggregator we're going to work on. But I'm going to try to mimic it so it kind of follows the logic of the way that the appellate courts in Texas assign my cases when I appeal something, right? So I'm going to ask Gemini to select randomly a court from this set of courts. I'm going to say the first appellate court. I'm going to say the first appellate court. And I'm going to say the first court of appeals. I'm just going to pick one randomly. Okay, the winner is the first court of appeals. Okay, so we're going to work on that one. It's a very random selection algorithm, very similar to the one that they use to route my cases, right, when I appeal. So we're going to work on that one. So the next thing we're going to do is we're going to go to BigQuery. Okay. So now this is the beginning of the Codelab. Okay. So now I'm going to give you steps, and I'm going to do them here in front of you. Okay. And we're going to develop these things together. Okay. Right. So I may get stuck here or there, right? But please bear with me. And because I need the two hands, the sound may get a bit degraded, but yeah. So I'm going to go to BigQuery. Okay, and BigQuery is a distributed database that is offered by Google Cloud that has tremendous capabilities in terms of scale. Right? And my end goal with this is to analyze a data set that I prepared for this random court that we just picked. Okay, and this data set was derived from public records. And I'll share with you, I'll open source the scripts that I use to gather this information from public sources. So it's basically a CSV file that has been gathered from public records using Python scripts. And I have the Python scripts already developed, and I'm going to share them with you. So this will work in Texas, but if you want to do this in another state, you have to tweak these scripts to reflect the public sources of your state, right? But for now, I have these already. These data sets already compiled, okay? And what these data sets contain is a collection of cases, of parties, really, in cases in this court that was randomly selected a few minutes ago, right? The First Appellate Court of Texas. So the first thing we're going to do, right, in BigQuery, you're going to go to this right side hand pane that you have here, and you're going to click on data sets. Okay. And you're going to click, it has, when you mouse over it, there is a small 3 dots menu that appears here. Or you can click on this one, it's better, right? It says create dataset. My goal is to create a dataset that will contain the tables for this demo alone, in isolation, okay? So I'm going to call it Adams because of the department, right? This hypothetical FBI unit that I'm proposing could be created, right, at some point in the future. That stands for Administration of Justice. What is the full name again? Administration of Justice, Deception, and Malfeasance Section. Right? So the short name is Adams. So it's going to be like that. First Court of Appeals, Codelab. I'm going to call my data set like that. And I'm going to store the data in the US. This is important for latency. If you're in Europe, for example, it's better to store it in Europe, so the latency of the queries is lower, okay, from your computer. This depends on where you are. So because I'm in the US, I'm going to store it in the US. Okay. Okay, so I created, so now I'm in the dataset, but I don't have any tables, okay? So the first thing I'm going to do, I'm going to import that table that I produced from public record. And I'm going to share the scripts on how I produce this table, right? This I'm not including this demo because it's a process that, to run those scripts, it takes like 3 hours, right? So I did this last night because, they're gathering data from public sources, right? So I did this last night and I created this table. But if I do this in this demo, we'll have to sit here waiting for 3 hours, right? So I can't do it here. But I'll share the script with you. It's a very simple process. You just have to run the script and it just works, okay? It just produces the table. That's the output of those scripts. It's basically 3 scripts that I run, one after the other. The first one fetches the data, the second one parses the data, and the third one hydrates the data, meaning it computes things from the data that was extracted and parsed, right? So now I have the data set, I'm going to create that table. So I'm going to upload that table for this court that was randomly selected, the first court of appeals. And I'm going to upload that table and it's going to be created in this data set, okay? So that's the next thing I'm going to do. So when you click create table, you select, if you have the table, right? Like in this case, you select here from these options, upload, meaning I'm going to give Google Cloud the table, right? Then I select the table and I have it in a directory here that is called this, and this is the table, right? It's called Court of Appeals. It's abbreviated, right? 01, augmented, hydrated, right? Because it's between augmented and hydrated. So the 3 steps that I described before. So that is the output of those 3 steps. So I'm going to select that, and I have to name it, right? So I'm going to call the table First Court of Appeals of Texas. And I'm going to also include the name of the Chief Justice, who is so Chief Justice Adams, right? Just to have in mind who manages that court. And I think that's it. Oh, you have to select, auto-detect the schema, because I'm uploading the table as a CSV table, right? So this allows BigQuery to look at the fields and infer if it might be a string of text, or if it might be a number or a float, or or what it could be. And this it's not very accurate. Like sometimes you could have a field that it's really a float, but BigQuery thinks it's a text, right? So we may have to adjust this in a subsequent query. But for now, I'm just going to import it using the auto detect feature, which is the easiest way to do it. And I want to click on create. Okay. It's done. It's created. So now I can go to the table. right? So here you can see the schema. So these are basically the different fields that I had in that table, produced by these scripts that gather all this information from public records. There's nothing proprietary here. All this is public records. So I'm just going to read the fields so you have an idea of what I'm getting with these Python scripts from public records. So you have the court name, the cause number, the party, right? So each party on that action in this first court of appeals is going to appear as a separate row in this table. So for example, in my case, with my former partner, there's 3 parties, right? Me, the realtor, the judge, for example, Judge Brown, who was appointed by Governor Abbott. So that would be the respondent, right? And my former partner would also appear as a party because she would be the real party in interest. So in that example, there would be 3 rows associated with this case number, 3 separate rows, 1 for each party. So that's party. Party type says what type of party it is, right? Or if it's the realtor, if it's the respondent, if it's the real party in interest, or other party, right? There's also a field for the representative. So each one of the attorneys that are representing that party. So for example, in this example that I'm giving you, my former partner would have Troy Pickett, right, in that field. And for that representative, I also have a structured data, and this is this is populated here by the Python scripts. The honorific prefix, the given name, the family name, the honorific suffix, the law firm, the address of the attorney, the phone number, the latitude, the longitude of the address of the attorney, the street number, the street name, the city, the zip code. So I have all these parts as structured data, right, in this table. And the same fields, but for the law firm itself. So for example, Troy Pickett, right, he supposedly works at OW Lawyers. So in this table, in the entry corresponding to him in that row, we will have his address and the address of the firm. That may or may not be the same, right? May differ. Also, the law firm is placed in there as a structured data, so it's parsed, okay? And it also has fields related to the trial case, meaning which one was the trial court, which one was the judge, which was the case number in the trial court, who was the reporter, if it's specified in the public records that I'm using to get this data, the punishment, if any. And these are metrics derived from the docket in the first court of appeal in this case, right? One is how many events are in this docket. That's the number of case events. Also, another metric that is interesting, and it's going to be interesting for us later on in this Codelab, is the number of cases that the case was open. And another metric that is also derived and interesting is the number of unique days with events. So if you look at a docket, in fact, let's do it here, right? So if you look at, this is a docket for my case, right? For one of my 2 cases in this court. So you can see, if you want to compute the number of days open, what you have to do is subtract December 10, right? Because that's the last event in the docket, from November 21st, right? So this is about 20 days. The case was open, and it's not really true because the case was dismissed on 11/25th, but because they're entering this thing yesterday, it kind of increased the apparent time, right? But let's say that it's 20 days. But the other metric is how many of these days are unique, because if you notice, right, there's 4 events on a single day. So what this means is that they did something, but it caused multiple entries by the clerk. But this doesn't mean that these are real, meaningful actions, right? So another interesting metric is, okay, let's see how many unique days were days in which action was taken, right? That's a different metric that is also interesting. So I'm computing that and putting that in that table. Now I want to see, this is interesting. For example, the latitude and the longitude did get recognized as floats. Sorry, you cannot see that because, let me increase this. Okay, so you can see that right here, right? So, for example, here, you can see the latitude and the longitude got recognized as float. Float is a decimal number. And that is important because we're going to do something with those numbers. We're going to join them with the geoindex of Elon Musk that Diosdado Cabello gave me, right? So the goal here, the end goal, is for us to understand which one of these parties or attorneys are marked in the index, right? To see, and then we can do very interesting things with that. But I'm not going to get ahead of myself. Let's work on that problem first, okay? So if you want to see a preview of what this table looks like, right? Here is some of the data, right? So you can see that it has in the first column, let me reduce it a little bit so you can see it better. Right, so it has the court, it has the case, the party type, the representative name, all that, right? All the good stuff that I described. Okay. Hmm. Right. So this is a good example. See, well, you see, some of the rows have null in, say, the given name. What this means is that the representative is somebody that, given this Python script that I built, right, it was not able to match it to an attorney with a bar of Texas number, right? So that's why that field appears. So for this demo, I'm gonna concentrate only in the ones that were definitely matched, right? So the ones that I'm sure this is an attorney registered with the bar of Texas. So I'm gonna concentrate on that subset, which is a large number, right? I mean, of this sample, right? And to give an idea, right? I don't know if you see, right, but if you saw this, but in my case, right, the case that I had, which was dismissed just on November 25th, right, you can see that the case consists. I mean, there's a format in this, and this is only in Texas, right? In different states would be different, right? But in here, this format is predictable. So the first group of digits imply the court. So 01 means that this is the first court of appeals, right? 25 is the year. So it means that this case started on year 2025. And this number over here is the sequential number of the case, right? So this tells you that this court has processed around 1,000 cases in 2025, right? That's important information. So out of those 1,000 cases, of course, some of those numbers might be invalid cases. Like somebody filed something, but then the case got deleted or whatever, right? So from the numbers I saw, I think from the 1,000 possible cases, right, or IDs for cases, I think there were something like 700 that were valid cases, right? And out of those, I think if you look at BigQuery, they produce something like 2585 rows, because each case has multiple parties, right? It would have the appellant, the respondent, and maybe could have even a real party of interest that might be different than the respondent. So it could be 2 or 3 parties per case, right? And if you multiply 700 by 3 is 2100, right? So it aligns, right? Right. So in this, I'm just gonna do some, easy queries here to show you that you can do queries in BigQuery and get data from this, right? Right here, like without doing anything else, if you want to, right? So being in the table, you can click on query, and that will open a tab that will have kind of a. I need to put this in a way that it looks better because. Okay. Okay. There is a button here that says more format query, right? So this will format the query so it looks better. Okay, so this is just doing a select, right? So I can do select asterisk. Asterisk means everything, right? Give me all the columns from this table and give me just 10 columns, right? Just in this example, if I click run, it will give me just 10 random columns, right? But I also can do things like, for example, I can say count party from this table where family name is not null. So what I'm trying to count is how many got parsed correctly with first name, last name, etc. Right? Because this has a space in the middle, you have to put backtick on it. So it gets recognized as a field. Right. So there are almost 1,000 parties in this data set that have been parsed correctly, right, as attorneys. So these are 1,000, almost 1,000 observations of people that I know for sure are attorneys. Now, there could be repeated items in here, right? Because an attorney could have had multiple cases before this court. And that on itself could be an interesting signal, right? Repetition, right? How many times this attorney has come to this very same court. And after that, we can also look at things like how many times they've gotten a favorable result, right? Or decision. But, let's not get ahead of ourselves. So if you wanna understand the repetitions, right, you could do something like this. You could select, right, let's call it party. Yeah, select the party, right, and the count of the party where the family's name is not null, and then you can say group by party. Right. So what I'm doing here is aggregating them by the first name, by the full name, and order by to descending, and then sort them by the ones that are most repeated on top. Right. This is an example to show you that I can do this complicated metric computation with this thing. Right. Just writing queries. Right. So, for example, the city of Houston has seen 15 cases, right, before this Court of Appeals. The state of Texas, 11. Right? I mean, that is understandable because those are institutions of the state. But this looks odd, right? Like the transocean offshore deep water drilling, like 9 cases. It's interesting. Now, also, we can go deeper on this and we can see what type of party they were, right? Because maybe in some cases they were appellee, and in some other cases they were appellant, or I don't know, right? Respondent, whatever, right? So I don't know. We can also do party type, but then if we do that, we have to group by party type. So by the tuple, right? By the two things in combination. And we're going to sort by 3 because now we're adding a new column, right? Okay, so this is interesting. Out of the 9 cases, right? This is very interesting. Out of the 9 cases of this transocean offshore deep water, and it's interesting because it's an oil company, right? Or probably oil service company. And, oil companies are a big part of this network, I mean. And there's 20, well, yes. There's more cases because there's another, I mean, this one did not get put together with this one because it has other parties in it, right? But it's also real party of interest. So we have to add the 2. So among the 2, yeah, this is very interesting. This transocean, and this is what I meant at the beginning, right? I did not debug this, and I'm just finding this real time with you here, right? So this transocean offshore deep water drilling Inc. combined with these 2 entities, right? In fact, you can also, to do it properly, let's add another condition just to filter by this, right? And contains, and I'm going to say that the party contains transocean. So I just want to understand how many in total contain this transocean, right? Transocean. Okay, so there is in total 16 cases in which transocean is a real party in interest, right? And if you compare that, if you remove that condition, those 2 together trump the city of Houston. I mean, this is an anomaly, right? How can, I don't know how big that company is, but how can a private company be present in more cases than the entire city of Houston before this appellate court? And always as a real party in interest, never as an appellant. Or Because if you think about it, right? Because it could be that the business they're in is highly litigious. It could be, right? But if that was the case, you would expect a reasonable split between cases in which they're being sued and cases in which they are suing, right? Or in which they're real party in interest and in which they are the appellant, right? The distribution shouldn't be 100% of one thing, 0% of the others, right? If the reason is that the industry is highly litigious, right? So that's one anomaly. And the other anomaly is that they have more cases before this court just in this year than the entire city of Houston, I mean, the government, right? I don't know. It just, and not only the city of Houston, all the state dependencies, like the city of Houston, the state of Texas, Harris County, like none of them win over Transocean offshore deep water. It's an interesting observation. So you see the power of this, right? But now, this is just public records, right? All I'm doing here is operating on public records. But now we're going to inject the nuclear power into this. We're going to add to this the geo-index of Elon Musk, right? And Travis Kalanick and those guys, which is really the geo-index of the Communist Party of China. That was given to me by Diosdado Cabello on September 11, 2024. So we're going to join this data because remember, in the columns, I have the latitude and longitude of the addresses of these attorneys and their firms, right? So we're going to join this data with the data in the geo-index, with the crypto payments score, for example, and with the espionage score, because I have the two scores compute separately. So we're going to try to join the points together to understand if the attorneys or the firms are marked in the index, right? I don't know. It could be an interesting thing. Like the other thing that we can aggregate hereby, I'm just thinking about this, right? Is about the law firm, right? Let's add to this aggregation the law firm to see if Transocean offshore deep water always use the same law firm, right? Or the same attorneys. So for that, we will have to add this field, law firm, right? To the aggregation. I mean, to the select and to the aggregation, right? So we have to, and the group by, we also have to add it. And because we're adding another column again, we have to move the sorting, instead of being the third column, to be the fourth column, right? I just want to see what is the of Transocean specifically, right? Yeah, they always use the same law firm. Well, I mean, this is the one that has the most cases. Not always, right? So this one, Amat, Savitsanos, and Mensing PC has 3, 6, 7, 8, 9, 10. They have 10 out of the 17 cases, right, that this company has or had before the First Appellate Court. So more than half are handled by that firm. But there are other cases that are handled by Montelongo and by Wright, Close, and Barger, right? So those are the two firms. Very interesting. Okay. Okay, so we were talking about joining the data. Okay, so to join the data, and I haven't done this before, and I have to apologize because I haven't worked on this type of projects for a couple of months, right? So my memory might be a bit rusty, so I'll have to. But this is good because if I get blocked, you will see how I find the answer, right? And then you will be able to replicate. So the first thing I would do, I will go to spyhealth.org/evidence. And I'm going to do Control F and look for Musk, because that will give me this sample, right? The sample query. But from what I really want from this sample query is this, the table, right? So this actually the project ID only. Right? So the next thing I'm going to do, I'm going to duplicate this page. Sorry. I'm going to duplicate this page, so I have two different tabs, okay? Because I need one tab to see the data and another tab to write the queries. So I'm going to take the project ID and I'm going to put it here where it says project equals. Right? So my goal with this is to be able to see the data and see the tables, because I don't recall exactly which are the tables that have the espionage score and which are the tables that have the crypto payments score. I know there are two different tables. So I'm going to click on the data set on itself, so which is this one, and sorry, the project, the data set, and these are the tables, right? So I can tell you the one that has the crypto payments is this one that says paramilitary worldwide, right? So this has all the positions in the world, and it has the crypto payments. And the one that has the espionage is this one that says spy assets worldwide, right? So the keyword here is worldwide. These two tables that say worldwide, okay? Now, these tables are huge. Like, if you look at this table, I'm going to show you this so you understand the volume of this um, Communist Party of China operation, right? So if you click on details, you will see that this thing has almost 1 billion rows, right? So there are 1 billion with B, 1,000 million locations marked in this index, in this table alone, plus the other ones in the other table with the espionage points, right? So put that in perspective, right? Okay. Okay, so what I want to do is look at the schema to remember. Okay, so the fields that I'm looking for are latitude and longitude. Okay, so now here I'm going to show you a little trick, because this table is huge, right? And if I operate on the table, I mean, BigQuery is fast; it will do it in seconds. But you know, it also has other effects, like you pay in BigQuery for the amount of data that you process, right? So I mean, and it's very cheap; it's very inexpensive. Like if I do this query, the query would cost, I don't know, 10 cents, right? But you know, to do it in a proper way, what I'm going to do, I'm going to create a view, and I want to do this to show you how to use BigQuery, right? Like how to give an example of how I would use it, right? To do this in a proper way. So what I'm going to do, I'm going to first do a query on the table from the first appellate court, because I have the latitudes and the longitudes there. And I'm going to compute what is the maximum latitude, what is the minimum latitude, and what is the minimum longitude, and what is the maximum longitude. So basically what I want to do is to create a bounding box, right? The maximum area that I need to pick that would contain, so I mean the minimum area that I would need to create that would contain all these actors, all the law firms and all the lawyers, right, that are in that data set. And then with that bounding box, I'm going to come to this other query and to this other table. I'm going to use this other table, and I'm going to create a view of it. I'm going to create a version of this table that only contains the point that fall within this bounding box, therefore eliminating the rest of the planet. So I'm going to create a version of these two tables that are only restricted to where these firms are located, to the minimum area that I need that will contain all these firms and lawyers, right? So this will give me a very small version of the table, right? That will be run very fast, and it will be very, very cheap to do queries on, right? So that's what I'm going to do. That's my game plan, right? If it works. As I said at the beginning, I'm, I may get stuck, right? And if I do, you know, I apologize. But I'll try to do it, you know, correctly, right? So the first thing I'm going to do is to do a query, right, on this table that I have. I'm going to do a different query, so I open a different tab here, okay? And in this query, I'm going to do this. Select the max. The max is a function that you can give it a field, and it tells you the maximum, you know, the maximum value it has, right? From the latitude. Sorry, I have to do this first. Okay. As max latitude. Okay. So what I'm doing is picking the max latitude and the minimum latitude from the table. Okay. And I'm going to do the same with the longitude. Okay. This is what I meant at the beginning, that this will be a bit slow because I have to type all these things, but my goal here is to give you something that is reproducible, right? So you can, if you're interested, you can play with it and also derive your own insights, right? Because there will be things that I will miss in this Codelab, but you can find things that I didn't even think of. Okay, so I'm doing that, right? So with that, this is not entirely correct. It's missing something, and I'll tell you in a second what it is. But I'll just run it to see if it works, right? Okay, so max latitude, mean latitude. The thing that is missing is that, remember, I have the attorneys and I have the firms that the attorneys work for, right? And those also have a latitude and longitude that may or may not be the same. So I need to take into account not only the attorneys, but also the firms, right? But to do that is easy. What I have to do is duplicate this, right? And I have to change the name of the field. I don't know what it's called. Okay. I'm missing a comma here. I think I have to look at the schema, because schema. Okay. So it's law firm from places API latitude and law firm from places API longitude. Those are the names that I'm looking for, right? So instead of latitude here, I'm going to say law firm from places API latitude, right? Law firm from places API longitude. Right? So now I have the 8 values, right? And this I have to also add something that differentiates it from the other, right? So I'm going to say max firm latitude, min firm latitude, max firm longitude, and min firm longitude, right? Mm-hmm. Okay. I think I repeated something. Longitude. This is okay. Okay, so now I'm going to run it. I'm going to inspect it to see if there's differences. See, so there is here you can see that I could have made a mistake, right? So at the beginning, so for the lawyers, for the attorneys themselves, the max latitude is 42.50, but for the firms is 49.28, right? Because of what I'm saying, there is somebody that the address of the attorney is not the same address of the firm, and they differ and they cause this difference. But if I want to create a bounding box that covers everything, the attorneys and the law firms, I have to take the maximum and the minimum across the two sets, okay? So what I'm going to do next is I'm going to wrap this query in another query, right? So I'm going to say select max from max latitude, right? Max firm latitude. There's an example, right? From, and then I'm going to grab this. I'm going to grab the previous query into this outer query, right? And what I'm doing is saying to BigQuery, from the results that you got in the previous query, select these fields in this way. It doesn't work. Okay. Okay. Well, if you get stuck like this, the first thing I would try is to try to ask Gemini, right? I'm going to say produce a BigQuery SQL query that computes the maximum and minimum latitudes from these two sets. I don't know if it will do it, but I'll try. How did it do it? Oh, it did union now. Okay, yeah, I understand. Yeah, that's probably the best way to do it. Okay, so I'm gonna do that. I truncated the table. Okay. What? Let me see. For some reason, it's not letting me copy this value. Ah, because it's in a different project. Is that the reason? No. Okay, if I do that, it does work. Hmm. Okay, this one. Okay, let's see if we can save it. I don't know. Okay, let me see if I can copy this now. Yes. Okay, so now I have the maximum overall latitude and longitude and the maximum overall, the minimum overall latitude and longitude. So with these four values, I can construct the query now, right? To basically filter those worldwide tables that I have in the other data set, okay? So let's start with, let's create a new query, right? So for that, you can come to the data set where the one that we found in spyhell.org, right? And we digged into the data set, found the tables. So I'm going to start with the crypto payments table, okay? Which is this one that is called Elon Musk military and paramilitary positions worldwide. So I'm going to click on, let me expand this a little bit because it's a bit hard to see. So I'm going to click on query, okay? I cannot really run the query in this project, but my goal really is to copy this part, to copy the location of the table, okay? And I'm going to take that to my project where I can run queries, okay? So I'm going to do select everything from this table, right? But I'm going to put a set of conditions, right? The conditions are where yeah, let me think about this for a second. Yeah, let's do it this way. Okay, where latitude is greater or equal than, and then I'm going to put the minimum overall latitude that I found, right? The overall minimum latitude, this one, right? So these are the set of conditions that I'm putting, right? And that latitude is lower or equal than, and then here I'm going to put the maximum that I found, right? The maximum overall latitude. Right? So what I'm doing is creating the bounding box to restrict my, geo-index, the geo-index data set that they gave me, right? To this small area that is of my interest in this project, in this Codelab. Right? Latitude, okay? And another condition would be that the longitude is greater or equal than the minimum that we saw overall. Right? And is lower than the maximum overall. Right? And again, as I said at the beginning, this is a tremendous amount of data, but you see how fast BigQuery is. It's amazing. Let's run it. And here you can see the steps that it's executing. Done, right? So it took 14 seconds, right? And in total, in this area of Houston, from this table, there are 174 million points, right, in the database. Mind that. Okay, so we have that. Okay. Now what I'm going to do, I'm going to save these results, okay, as a new table. But I'm going to save it in my project, in this project for this Codelab, with a name that tells me that this is coming from this is the military and paramilitary table, which is really the crypto payments, right? So this is the crypto. Okay. So I'm going to save this as a BigQuery table, and I'm going to put it in. I should be able to put it in this. Give me just a second. I should be able to put it in this data set, right? Let's save it here, BigQuery table. Oh, it's not in the same region, imagine that. Okay, so I have to create a new data set that is in the same region. I didn't remember this. There is a restriction because I have this table that I'm querying in a particular region. I have to create a data set that falls in the same region. So I'm going to have to create that data set here again. I'm going to have to create a new data set. That's what I mean. That is in the same region. Okay. Okay. So I'm going to say create new data set. And the data set will be, okay, it's in the central. It's in the central area. Okay. It's going to be Adams because this is a hypothetical department of the FBI, right? That I'm hypothetically creating in this example. First Court of Appeals, Texas. Okay. I'm going to create that data set. To differentiate it from the other, I'm going to put a suffix that says that this is in US Central, okay? Just so I know what it is. Okay. Okay, and this table would be Diosdado, Cabello, crypto, payments, Houston area, I'm gonna say. Okay. Okay, the table is created. Okay. Now I'm going to repeat this process, but I'm gonna do it with the other table, with the one that says SPY assets and locations worldwide. Right? By the way, this thing I'm doing is exactly the same procedure or the same kind of technique of debugging that I was doing on April 16, that when I started doing the queries to Google Maps API, Morgan Heibner and William Kyle Adams dispatched a process server to serve me documents and harass me here in my home. Like he trespassed, like there was a whole incident, right? Then I called 911 to report the person for trespassing, and Deputy Walker came to my home and he didn't take the police report. He refused to file the police report. So what I'm doing right now is exactly the same I was doing that day. And within 20 minutes, they dispatched the process server. I'm saying that because I'm expecting to see if they're going to send another process server today while I'm doing the demo, right? Maybe, I don't know. Let's see. So, okay. So what I'm doing now is picking the other table, which is this one, right? And I think SPY locations. Okay, this is the other one. Okay. So what I'm going to do, I'm going to click on the table, right? And then I click on query, and that will open a new tab that will have the select from statement. And what I really want is the from. Okay, what I want to do is to take this string to produce the other query, right? So I can come here, right? And I can basically, this is a little trick that I'm going to show you. You can put the other statement here, and you can comment out the first one by saying dash dash. So that makes the first one inactive, right? It doesn't do anything. It's like a comment. And then I'm basically switching to the other table by doing this. And then I'll run it. And remember, the other one produced 174 million points, right? This one, let's see how many it produces. This one produced 243 million, which makes sense, right? If you think about it, because this has the logistical points. There are more logistical points than payment records in this system, because there are more people that they have running around with the cars with the Chinese espionage machine than people that they actually pay crypto to, right? So it makes sense. But now we have the two tables, okay? Now I'm going to save this table also as a BigQuery table in the same data set that I just created, right? This one that says Adams, First Court of Appeals, Texas, Chief Justice Adams, U.S. Central. And I'm going to name this table as CPC for the Communist Party of China, espionage, logistical points, Houston, near Houston. Okay. And I'm going to save it. Okay. The other thing I need to do is, because remember, now the problem I have is that I have two data sets that are in two different Google Cloud zones. One is in the US as a global region, and the other one is in US Central, a specific subregion. So I need to move or copy the first table that I had with the cases, remember, to this other data set. So I have everything in a single data set. So to do that, right, I'm going to click on data set, refresh, right? So here you see I have two data sets, one that says US Central and one that doesn't say it because it's in the US. You see the locations are different. So what I'm going to do, I'm going to take this table. Ready? Refresh. Okay, there it is, right? And I'm going to copy this table. Well, to copy it, what I can do is I can do a query, right? And I'll save the results as well. And you see that it has 2,580, so 2,585 rows, which is what we saw before. So no data was lost. Right? It's important to always spot check that you're not losing anything. So I'm going to save that to another BigQuery table, and I'm going to put it in this data set that I have. No, this is not. It doesn't let me do that. Oh, I see. Okay, so in that case, what I'm going to do, I'm going to go to the other data set, I think. Yeah, I think. And I'm going just to import the table from scratch in the other data set. It's easier, right? So I'm going to go to this data set, right? I have these two tables that I just copied. They are a restricted version of the bigger tables, right? And I'm going to click on Create Table. I'm going to say that I'm going to upload it. So the same thing that I did before, right? I'm going to select this from this file that I have that I built with the Python scripts. Okay. And I'm going to name this the First Court of Appeals Cases 2025, Chief Justice Adams. Right? Because he's the Chief Justice that manages this court. And I'm going to auto-detect the schema. And I'm going to create the table. So this is beautiful. At this point, I should have here my three tables, right? So I should have here the cases of the First Appellate Court with the attorneys, with the law firms, with the latitudes and longitudes, and with those metrics I computed for cases, number of days, number of unique days, number of events in the case. And I have my other two tables, which are decoded from the GeoIndex of Elon Musk that was given to me by Diosdado Cabello. So now we can merge them, we can join them, right? So let's start with the logistical points. The logistical points, there is a field that is called Musk Kalanick Omidyar Field Evil Score. Right? And the name sounds theatrical, but sometimes I do this thing where I give names to the signals that to honor the people, like the Heibner boost, right? Like that signal is named after Morgan Heibner because she allowed me to see this thing, right? So I have to be thankful for that, and I have to recognize her contribution, and I do that by assigning the name. So this is a score. So I'm going to write that query here, and let me see. So one thing I will need is a table, right? This table. But the real table that I'm going to query is not this one. What I'm going to query is the cases, right? So I'm going to join the cases with the other data, right? So I'm going to write that query here. Okay. So I'm going to select from the cases. And here I'm going to use a few tricks that I've learned over the years about BigQuery and SQL. So I'm going to give a name to this table, right, as cases. And I'm going to do a left join with this other table. and I'm going to call this as logistical points on yeah, let me think about this for a second. So I'm going to do so basically what I'm going to do, I'm going to join. So I have the cases, right? So I need to join the cases. I need to think about this to do it in a way that it scales, right? Because when you do a join, I'm going to end for each row in the cases. So I have 1,000 cases, I have 1,000 how do I say this? I have 1,000 rows that resolve to an attorney, right? So if I do a join is basically you're putting one table and next to the other, and you are matching fields. You're matching the two tables by a single field. So if you do that, there might be multiple fields that will match, right? For example, let's say that you have 3 attorneys that are in the same coordinates. And in that other table, you have that coordinate, right? So this will cause that 3 different rows will match. And so you will be increasing the number of rows. And it could get to a point where it doesn't scale. But let's try, right? Let's try it to see what happens, right? So, one thing that you can do is ask here, right? BigQuery produce query to join these 2 tables by fields name, latitude, and longitude present in both tables. Right. Yeah, let's see if it runs. My fear is that it might explode, right? Because the Cartesian product might be very large. Let's see. It does run. This is interesting. Oh, because yes, I know why. Because I already normalized it in the other tables. So, the way the GeoIndex works, this is more complicated explanation, but they have multiple points that are close together, right? No, this is not the reason. The reason why it's giving me this product is because the latitudes and the longitudes are very specific, right? I mean, in the table of the attorneys. I mean, these are 7 digits, but the ones in the GeoIndex are 4 to 5 decimal precision. So what's happening, I'm guessing, right? Let's see if I'm guessing this right. We'll check in a second. But I'm guessing that what's happening is that non-match. So in reality, the join didn't work. So if I go to the right, see, all the fields are empty because the match did not work. So this is the problem, right? Because they're floats, we cannot do equal because they're not really equal and they will never be equal, right? So the matching condition, it has to be way more complicated than this. What I would propose, and this is me just thinking as an engineer, right? I don't know the solution to this yet. Right? This is me getting a stock right here, right? I'm a stock. I need to get on a stock. So what I propose to do this join would be to, instead of doing an equality comparison on the join, what I need to do is to subtract the 2 numbers, the latitudes, and make it so, make the condition be that the absolute value of the difference is lower than a small number, right? And that what that number is important, because if that number should represent how far away the point can be to this be considered a match. The logic here is that this network is not going to allow a prominent attorney of their network to be in a location that is next to something that is not compromised. Like even if the point is not exactly in the office, if the point is 100 feet away, that attorney has to be compromised, because the network is not going to let a non-network attorney be so close to an important operational point by pure logic, right? So I don't really need to match the points. What I need to match is the proximity to the point, is what I'm trying to say. So what I'm going to do, I'm going to subtract the two components of the coordinate, and I'm going to make the condition be that the distance, the difference between the two components is not big, right? But that what that big is, that number, that delta that I will allow, has to represent what is the maximum distance that I will allow, right? And this distance depends on the latitude, because the higher you go, right, in the globe, in the Earth, these decimal points in latitude or longitude have a different, because the shape of the Earth is not round, right? So I mean, this is it's a bit complicated, right? But we'll simplify it and approximate the problem, right? Instead of getting bogged with the details. So what I'm saying is, the proposal is that instead of doing equal, right, I'm going to do a subtraction, right? And I'm going to compute the absolute value of that subtraction. And I'm going to say that that absolute value has to be lower than, and I'm going to make up a number here, right? And then we'll adjust this number, okay? Okay, something like this, right? Let's see. See, so this is a way more complex query. And you can tell that because of the amount of time that it's taking, right? The previous one came back in something like 12 seconds. But this one, it's taking a while. Let's see. I'm hoping that it doesn't explode, right? Because like you see, there will be multiple points that will match this condition, right? This is the problem. And this will create a Cartesian product that will explode the number of possible rows. The number of rows in the result is going to be thousands of times more rows than in the original table, right? So it would be something like multiplying 1,000 by, say, 174 million, right? So we're talking now about 174 billion, right? This could produce up to 174 billion rows in one table, and up to 224 billion in another table. So we're talking about the orders of magnitudes of almost trillions, right? So you see how fast this gets out of control, and this is because BigQuery is a very powerful tool that can do these super high-scale computations, right? Now, while that runs, the good thing is that I can run multiple things on parallel, right? Because all this is running on the cloud. So one thing I'm going to do, I'm going to restrict. So one way to reduce this is to reduce the size of the problem, right? To avoid this from exploding. This one I think is going to explode. To be honest with you. So one thing I can try is to reduce the number of matching rows in the Cartesian product. There's two ways to do that. One is reducing the number of rows in one table, and the other one is reducing the number of rows that match the condition. So I can reduce it on the first table because I can say, for example, that only consider the attorneys that have a latitude that is not null. As we saw before, there are a lot of rows in that table that the latitude is null, because the name could not be resolved to an attorney. For example, me, right? Because I'm acting pro se in that case, my name does not resolve to an attorney name. So in my case, my latitude and longitude as an attorney are null, right? So why go through the trouble of computing that, right? So I'm going to make another copy of this query where I eliminate that by putting that condition, that constraint. And the other way I can reduce the number of matches is by making that delta that I allow in that app's computation to be smaller. Because the smaller it is, the less rows that will match, right? That will match the join. So I can play with those two constraints, right? So I'm going to create a new query, like to play with that. So for that, the first thing I want to do, I'm going to wrap this into a select, right? Select. Okay. So that reduces the number of rows in one table, right? And in fact, we can check how many rows that would be, right, by running that query in isolation. Right, so this would produce 935. So I eliminated half of the rows, right, in one shot. Let's see if this is still, did it run? No, it's still running. Okay. So I'm eliminating that way, right? And the other thing I can do, let's, add 2 decimals to this. No, I think it's too much. 1 decimal. No, but the problem is that no, it's going to explode because the problem is to be able to compute the absolute value, right? You need to do the multiplication, right? So you need to do the subtraction, right? So this is forcing the full Cartesian product of the 2 tables. That's the problem. So I mean, I can only optimize one of the 2. This is interesting. It's an interesting problem. Um, mhm. I'm just trying to think, right? What solution could there be? Another solution could be on the second table, right? I could try to eliminate all the rows that are not close enough to any of the attorneys, right? Or the law firms. So do it by steps, basically. No, it's the same problem. It's going to result in the same. Let me see. Let me see. Hmm. Okay, I think I know what we can do. Okay, let's try it. And like this is what I was saying at the beginning, right? Like this is me getting a stock. Okay, so this is one way to do this. In BigQuery, there are a set of functions that let you compute from a latitude and longitude the S2 cell. The S2 cell is a concept that they use at Google internally to represent a geographical area, like a bounding box. So the idea would be, instead of joining them, so instead of doing this complicated math with the latitude and longitude, right, which produces this Cartesian product, what if I compute first, in the first pass, the S2 cell of each row, right, in each table, and then I join by the S2 cells. If I make the S2 cell small enough, right, I would be accomplishing the same. But it's a much easier join because it would be a join by a string rather than by 2 floats that imply 2 subtraction, right, at this scale. So let me try that. So if I recall correctly, let me see if I can find it. Okay. Yes. This one. So basically, you pass. Yes. you pass the geography point, and you pass the cell ID. Sorry, the number, right? Because these are like zoom levels. Like these are the zoom levels that you see in Google Maps, basically, right? So the higher the number, it's more zoomed in. So what I want to do is do something that is very zoomed in. See, the cell levels are from 0 to 30, right? So I think I need something like level 21 or something like that, right? Which is like a house, the size of a house, more or less. Okay, so what I'm gonna do, I'm gonna create a query. Right? Create two queries that augment those two tables individually with the S2 cell of each point. Using an S2 cell level that covers around 100 feet by 100 feet in or around Houston, Texas. I don't know. I don't know if it will do it. Let's see. So it says level 16, right? That's what it's proposing. Okay. Okay. So I'm gonna run that query. This is still running, right? And to be honest, I don't think it's going to work. Oh, it did work. Oh no, this is the one that is wrong. No, this is not the one that is wrong. Did it work? I see one here that seems, yeah, it did work. So see, for example, this person, Amanda King, and we know King is a prominence name marker, right? So you see this one matched, and you have the data, right? Wow, this is amazing. So yes, so it has a score of 6, right? So this is the espionage one, right? This is amazing. I'm gonna save this just to see, right? If we cannot replicate it, then I'm gonna go to the other approach that we already identified, right? With the S2 cells. We can do the same with the S2 cells. We compute the S2 cells, and then we join by the S2 cell, right? I like this better if it works, the differences, because the S2 cells, the problem with the S2 cells is that you may have some border cases, right? In which the point falls in the border of the S2 cell. And then you don't match because one fell in one S2 cell and the other one fell in the other S2 cell. So, you know, it's more tricky, right? But I mean, if this works, it's better, right? Now, let's before we go there, let's look at and you know, like I find this part of the process very stimulating, right? Like it's because you have to think how to overcome this, and to do that, you have to be creative, right? Like the solution is not written anywhere. But see, what I was telling you before, that comment I made about that number, that 0.001, that number matches to a distance in the terrain, right? Because if you allow the latitude and the longitude to variate by that number, by that decimal number, you are basically allowing a degree, 2 degrees of freedom, right? In two axes, So the question I ask myself is, what is that degree of freedom? Like, how long is that area, and how it would compare to the S2 cell 16, level 16 that we saw that we could use, right? I don't know. I'm curious, right? Because maybe I made this too restricted, right? Maybe, I don't know, but I can't recall the number. So to do that, what I would do, I would ask this AI thing, right? The following question. A difference in latitude, in longitude, sorry, in longitude of 0.0001 decimal degrees maps to what distance in the following scenarios? Scenario A, in a latitude comparable to Houston, Texas. I'm just doing this to show you how the latitude affects this degree of freedom, right? B, in a latitude comparable to, let's say, Vancouver. So it's the same difference, right? 0.001 decimal degrees. But you see that it has two different meanings depending on how up north you are, right? Yeah, so I made this too small. See, it's only 3 feet, right? So this restriction that I put is 3 feet in, sorry, is 31 feet, right? And in Vancouver is 23 feet, right? So this distance is too small. I would like to make it a little bit bigger. I would say, by experience, right, working on this problem, I would say at least 5 times bigger. So I would put it at, I multiply it by 5, right, and rerun the query. So let's do that. Of course, this is going to make the query take longer, right? So what I'm doing here is more or less doing the same thing as that. From a practical point of view, it's the same as using the S2Cell level 16 that I was describing before, right? It's kind of the same thing. Okay, but I'm going to run this as a separate query. In case it fails, I don't destroy the results that I have, right? Okay. And the other thing that we need to do, right? Because it's possible. So we have to check the lawyer, because here we're only checking the lawyer, right? I mean, we're checking the latitude and the longitude of the lawyer, but we need to also check the latitude and the longitude of the law firm, right? That's the other possible match. So let's do that here, right? So to do that, I'm going to wrap this into a parenthesis here, right? And I'm going to say that I would accept that condition or this other condition, right? And the condition is going to be the same. The only difference is which field I'm matching, right? So instead of being latitude, I'm going to say law firm or firm. I can't recall the name. Let me find the name. Okay. Okay, this is the name. Okay. Okay. So they're going to match if the attorney is marked or if the law firm is marked. That's what I'm doing, right? And I'm allowing 100 feet radius, basically, for the matching to be accepted. Mhm. Okay, let's see. Okay. And because we know it's likely to work, right? We're going to do the same query, but with the other table. So we're going to run the two in parallel. Okay. Mm, the other one is well, the other one I can get it from here, right? Yes, the other one is I think it's this one, and it's called latitude and longitude, right? Yes. Okay. So for this one, basically, sorry. Okay, this is running. Okay. No. I'm going to open a new tab so I can copy that because I can't recall the. Okay. Yeah, so this part takes a bit of time because we're joining the data, but after we join it, then we're going to be able to see this visually very quickly. So it's this one, and I'm interested in this one. Okay. So okay. So on the second table that I'm going to join is this one. And I'm going to call it crypto, I mean the alias that I'm going to give to that table. And then that means that I have to fix this and fix this and fix this and fix this. Another thing you can do, you can save your query, right? That way, you can come back later and revisit this. So I'm going to save it. I'm going to say this is called crypto join for the first court of appeals cases. Crypto. Okay. And then this, I'm not able to save it yet, but I will. Okay. I'm going to run this to see what happens. Now, I would expect the number of rows of this to be greater than 935 because there will be multiple points that will match, right? Because I increased the area. Now it's not 28, or sorry, 31 feet. Now it's something like 120, 140 feet, like the radius that where I allow the matching. So I would expect these two queries to produce more rows, but that's not a problem because my goal at the end, I mean, the rows are going to be exactly the same, right? The attorney is going to be repeated, but it's going to have multiple points with different scores. Scores, I'm talking about scores in the geo index, right? And then I can aggregate them by attorney or by. So while this runs, because this is going to take a few minutes, let me think what's the best way to present this. Okay, so what I'm going to do, I'm going to start working, right, to save time while this runs. I'm going to start working on the dashboard. So my end goal here is to take these two tables, right, that are joined. Remember, these are the appellate cases in this first appellate court, where the Chief Justice is Justice Adams. And my goal here is to join this metadata that I have about this and metrics about these appellate court cases, join the cases with the points in the geoindex, both paramilitary, crypto, and logistics. And then ultimately produce dashboards, right? That allows us to see visually things that could be anomalies, right? That's the idea, to be able to debug things visually with dashboards. So I'm going to start working on those dashboards, right, to save your time. Okay, the first query came back, I think. Yes. Could it be? Yeah, this is interesting. See, so in the first time I ran it with a smaller size, there were 935 rows matching. The second time where I increased it, there's 959 rows matching. You see? So this is very interesting. It means that there are some that have multiple matches, right? Multiple cluster of points in at least in the logistical part. And in the crypto part, it's still running, right? But now we have something to work with. So now I'm going to save this table as in the same data set that I have, and I'm going to call this what was the name that we let's give it a similar name, right? It's always a good practice to keep the names consistent and just add suffixes if you need to qualify, right? So this allows you to keep track of what is that you are looking at. So I'm going to call it the same, but I'm going to add join with logistical points. Okay. Yes. It's saved. Okay. And the other one is running. But while the other one runs, we can start working on the dashboard, right? So let's go to Looker, the same tool we used in the last demo. And now here's where the fun part starts. Okay. So I'm going to start with this report because it's formatted, right? And it has the colors and it doesn't look ugly, right? So I'm going to start by clicking on Edit and Share. So this is the kind of a template that I can use to create my own report. Okay. And the first thing I'm going to do, I'm going to delete the things that I don't need. So I'm going to delete this. I'm going to delete basically everything. I'm just going to keep the colors and the basics. So I'm going to delete this. I'm going to delete this. This, and this. Okay. And what I'm going to do, I'm going to add a new data source. Right. I'm going to delete this one. And I'm going to add BigQuery. Right. I'm going to go to that project where I'm working in. I'm going to go to this one that says US Central at the end, which is where I have the tables, right? And here you can see that this is the table that I just saved, right? That has the points joined, okay? Okay, now I have the database, right? And the other one just finished running, okay? Amazing. And this one also has 957, okay? And just to double check something here quickly. Yes, the scores are in the other scale. So this tells me when you see this in this system, right, that I have, when you see the thousands, it means that this is a crypto. I put them in different scale to be able to differentiate them visually very quickly. So this one that says 4,000 is because they're crypto. Right? And you can see, how different some lawyers are to others, right? So this lawyer here has 72,000 points in the crypto payments space, while the one in the previous row has only 4,000, right? So you can see here that there's hierarchy, right, in this organization. So, so now we're cooking, right? Now what I'm going to do, I'm going to save that table as well, of course, right? To make sure that I don't lose it. So I'm going to save it as a BigQuery table. I'm going to put it in the same data set, and I'm going to name it the same, right? But join with crypto payments. Okay, and I'm going to save it. Okay, and I'm going to go to the report. I'm going to name this report Adams as this hypothetical unit in this hypothetical FBI that I'm creating. And this is the first court of appeals in Texas, right? And these are the cases for 2025. Okay. Okay. So now I'm going to add the nuclear data set that I just created. Okay. So now in this report, I have access to two separate data sets from two different tables, right? From two different sources. So this is the one, and this is the logistical points. This one is the crypto. Okay. This one is the crypto. Okay. Okay. Now, the other thing I need to do is the following, right? Yes. So in these data sources, right, if you click on edit on any of them, there's a field that says, address. Let me see. What is the address? Address. Okay, it's this one, right? Let me check that I'm looking at the right one, right? So the reason why there's two is because one is coming from one table, the other one is coming from the other. But it should be the first one that doesn't have a suffix address, right? So this is correct, right? Address. So here I need to mark this field as a geo field. So I can place it in a map, for example, right? And so you have to mark it explicitly here when you configure the data source. Otherwise, it doesn't work. So I'm going to mark it as an address, right? Done. And I'm going to do the same with the other table. I'm going to mark this as an address. Okay. Now, here you're going to see the power of this system, right? Now, let's start by this. Let's create a table, okay? And this table, and so you click on chart and you can add a table, okay? So in this table, we're going to add as a metric. The first metric is going to be the attorney, right? So I think it's called party name, if I recall correctly. You can do a search here, so you can search for party. Yeah, party is the no, sorry, representative is what we're looking for. That's the attorney, representative, right? Right. So here you have the representatives, right? So this is the attorney, right? And you have the record count. So how many cases are in this set in the first appellate court of 2025 where this was the representative, right? Next, we are going to add another metric. And this metric is going to be the score, right? Right. So the Mosk, Kalanick, Omidyar, field, able score. But because I don't want to oh, this is the same problem I was saying before. Let me add the score, the other one. Right. And we can sort by a score. By a score. What is it? In descending order. Okay. Now, it's important to put a filter in here to filter out the ones that don't have a score, because if they don't have a score, it means that they didn't match. right? So we cannot draw any conclusions from that. There might be other metrics like the number of cases, whether the cases were favorable, like all those things. But let's do this exercise strictly by the markers in the geo index, right? Because this is factual data that came from a database that Diosdado Cabello gave me, right? So let's put a filter in here, okay, to do this strictly in a strictly correct way, in which we're going to put a filter to say that this score has to be not null or has to be greater than 0, right, for the field to appear. So there is a thing here called filter. What is it? Matrix background. I don't say it though. Let me see. Oh, because it's in this tab setup, right? Filter. Okay, so this is a filter. I'm gonna create a filter that says include only the ones where the score that I'm looking at is greater. I'm gonna exclude the ones that are null. I think that is a better approach. Okay, so there are 92, right? So out of the 935 rows that had representatives that were resolved to lawyers, 92 are marked in the index, right? So 10%. Now, an interesting metric would be to compare that number from this court, from this universe, against other courts, right? To see if one court is more controlled than the other, right? But, let me delete this, right? Right. But, you can see the level of the scores, right? We're talking about thousands. To give an idea, Robert Mueller, his house, if you look it up, and we did this exercise before, right? Let's do it here so you have an idea, right? Because in these things, what is important is to be able to compare, right? The absolute value may not tell you anything, but the relative value tells you something, right? And remember, this is the part of the these numbers are coming from the encoder that is about crypto payments. So if you go to Lake Point Estates, right? Lake Point Estates. Robert Mueller's house is the one that has this mysterious structure in the backyard, right? This concrete structure where, I suspect the modem was at some point. I'm talking about the power line control, modem. But if you take this address, like the address of his house, and you go to spyhell.org and click on this thing that says paramilitary and crypto, which is basically querying from the same table, right, that I'm talking about. And you enter that address, you will see that the house is marked in the index, right? And it has the crypto payments. But the numbers are, like, you would have to add these numbers together, right, to compute. I would put it around here, right? So it's like 2,000 and 17,000. So 2 and 7, 19, 23, 30, 34, 35, 39, maybe 40,000 points, right? He has in this crypto payments marker in this index, right? And if you look at these attorneys, they are one order or even 2 or 3 orders of magnitude above Robert Mueller, right? In terms of this crypto payments metric. So, for example, this person, Chris Branson, I don't know who that person is, but it's in the millions, right? 32 million. Well, this could be coming from the firm as well, right? Remember, because we did the match. It's a broad match that matches the firm and matches the person, right? But if we're curious, we can add the firm itself as a dimension here, and we will be able to see in this table right here what is that firm, right? So we just have to search for firm and select this field that says law firm, right? Uh-oh. No. Let me see. Okay. So he doesn't have a firm, like when my Python script was not able to find the firm for him, right? But in these cases, because he's so prominent, I'm curious, right? So his name is Chris Bronson. How do I spell it? Chris Branson, right? Branson, attorney. Mhm. So he's the owner of his own law firm, right? And he's in Child Protective Services, which I mean, based on my own experience about the situation with the 387 and the kidnapping of my son using legal means, I can see how that would work, right? Um, oh no, it's not that it did not match the firm. It could not match the address of the firm. Is what it could not match. But the firm, maybe it matched. I don't know. So instead of doing this, I think what I'm going to do is I'm going to instead of the normalized firm address, I'm going to say firm address or address. Yes. Okay. Right. So this is very interesting. Now, one thing that we can do, right now that we're here, we can probably add a map to this, right, to be able to see it visually, like where these important attorneys are. We can probably do. I don't know. Let me see if I can do this. And in setup, yes. Right. Oh, it's amazing. I'm going to change the type of the chart to something more usable, right? Yeah, this is super interesting, right? But you can see that the concentration is heavy towards Katy, right? So it's towards the southwest. Like if you look at the, at the northeast of Houston, there's nothing, right? The focus of this network is in the southwest of Houston. In terms of this, right, of the attorneys that are using the appellate court in these different ways, because I can see how this can be used in different ways, right? It's not only to harm people; they could be used in other ways. Super interesting. Okay. But remember, this is only one table. Okay, so this is the one about the crypto payments. Now we can create a different view, and for that, I'm going to make a copy of this page. And to make a copy, sorry, I think I have to do something like view, show navigation, maybe. No. I can't recall what it. Okay, add page, right? Okay, so here I can do duplicate, right? So on this one, I'm going to name it crypto course, right? And this is different. This is espionage score. So these numbers will come from the other color, from the other table, right? And you can export these tables and download them if you want, right? You can click on this three buttons thing, and you can say export data, and you can export the data as a CSV file or to Google Sheets, and you can see it in Google Sheets, right? Okay, but I'm going to Where is it? View. I can't recall what it is. Where was it? Let me see if I can do this. Okay, here, right? Okay. So for this one, I'm going to do exactly the same thing, but I'm going to change the data source. So instead of using the data source that, oh no, sorry. Oh no, what I was showing you wasn't crypto, was logistical points. I apologize for that. I misspoke. So these ones are logistical points, right? So espionage points. So I'm going to leave that on the second page. And then on the first page, I'm going to switch it to crypto. No, it was crypto. I'm going to switch it, the second page, to logistical points. No, it was correct. It was always crypto. The first one, the UI is confusing, right? But this is interesting. So Chris Branson also has the highest score for the logistical points. So he has the two. He has the logistical and he has the crypto payments, which they don't necessarily correlate, right? But it means that he is important in the two dimensions, right? So this tells you that this is an important person, right, for this network. And in total, in the logistical side of things, there are 110. So there are a few. There's like 10 attorneys that are marked in the espionage side of the index, but are not marked in the crypto payments. So they're not important enough to get the crypto payments. So they're a little bit more, which makes sense, right? That you would expect that there's more people spying than people getting paid, because maybe they get paid in a different way, right? I mean, getting paid with the crypto payments. So that makes sense. But we also need to change the map to understand it, right? So I'm going to switch the map to logistical points. Right? And we're going to see. Right? So on the logistical point, they do have some more interest. I mean, the interest seems to be broader than the crypto payments, right? So there are some attorneys on the southeast and some on the northeast as well that were not there in the other ones. So I mean, that's another interesting observation, right? But now, and to be strictly correct, we should delete these things because this is not really from Google, right? And we should probably add. I'm still here. We should probably add a text input. Where is it? Where is it? Where is it? Where is it? Maybe this one. Okay, I'm going to say this is crypto. Right, this is the first page, crypto. And I'm going to increase the size. Right. And the second one is not crypto, it's espionage. Right? Okay. Now, but this gets more interesting. So now we can also add filters, right? So we can, for example, say, let me search by, let me add a filter here, right? So I'm going to add a drop-down list by the address, right? Okay. And I'm going to add another drop-down list by the name of the representative. And I'm going to add another drop-down list by the law firm, which is developer. I don't know why that isn't working. It should work. Will this work? Yes. Okay. The normalized one. Okay. And also, I'm going to add a couple of widgets. Okay. To be able to show you the power of this, right? So you can add. Yeah, I'm looking for something like this, right? Okay, so I'm going to here. I'm going to search for the cost number, right? And what I want to do is to count the uniques, right? Count this thing. Okay. So how many cases are we talking about? So this is wow, this is amazing. I mean, this is very interesting, right? So this is the kind of things that you see. And this is what I was telling you at the beginning, right? Like I haven't debugged this, right? I haven't encountered these things, and when I see them, right? It's impossible not to see them. I'll tell you what I saw. If you look at this, right? Sorry, let me show you, right? If you look at this, We're talking about that there are here 92 attorneys, and you can see that here, right? And remember, right? They were 935 rows in the data set, right? That resolved to an attorney. But the ones that are marked in the index are only 10%, right? 92, right? With the crypto payments. But if you look at the number of cases, they have half of the cases, right? That is a tremendous statistical anomaly. I mean, in a normal distribution, right? If you have 10% of the attorneys, you should have more or less 10% of the cases, right? I mean, yes, it's possible that somebody that was in the head got into the 10%, but I mean, you have here, half of the cases of this court are concentrated in a small group of attorneys, right? That's what this means. Small group of representatives that were matched to attorneys that are marked in the index, right? I mean, it's too many coincidences. And I'm not really, not even debugging this, right? This is so obvious that I just glanced at it and I saw it, right? Okay, so now we have here the number of cases, right? And I'm gonna put this with a name that is obvious, right? Okay. And I'm looking at the distinct, right? I'm only counting the distinct case number. So if this is, there could be 10 attorneys in the case. They don't count 10 times. They count only one time because I'm looking at the distinct number of cases, the unique number of cases, right? The unique cases. So that is not the explanation. Okay. So I'm going to create another metric like that, right? Another widget like that, I mean. But instead of measuring the number of cases, I'm going to measure the number of days open, for example, those metrics that I compute, right? So I have those numbers here, right? Number of days case opened, right? But it's not going to be the sum, it's going to be an average, right? It's going to be average. So these cases are open in average for half a year, right? Almost 6 months, right? 167 days in the average. I don't know if the median would be different, right? Let me see. Let's use the median, right? So people don't say that it was biased. So 146 days, right? So it's more than 3 months. In average, these cases are open more than 3 months. And another metric that I would like to display here is number of days number of unique days. So number of days in which there were unique events in the docket, right? Number, I'm going to say medium. 15, right? At the medium of the distribution, these cases have 15 unique days in which there are events entering into the docket, right? I'm going to tell you why I'm telling you this, right? I'm going to make a copy of this page. I don't know how to do that, to be honest with you. Okay, here. Okay. So I'm going to duplicate this page, right? And I'm going to say non-attorneys. Or not even that, not marked in the index. Right? And I'm going to add a drop-down list here that says party, right? I'm going to call it parties, right? I'm not bias you with that. I'm going to remove this. And here, I'm going to say, first of all, I'm going to remove that filter, right? So there's no filter anymore. And I'm going to remove the score. Right? And I'm going to add the metrics, right? So count, sorry. Number, yeah. Number of case events, for example. Number of case open. Number of unique days with events. Okay. But here, I think, yes, I should do that. So I'm going to add another data source, okay, which is going to be everybody in this court, right? Like not restricted to whether you're an attorney or not. So for that, I'm going to do this. I'm going to click on this, and I'm going to click on, I think it's this one. Which should have the 2,500 rows, right, more or less. So here, I'm going to select that one. And it says 1,900 rows. This is because multiple rows match in the same fields, right? So it gets aggregated. But I'm going to remove the firm's address because I'm just interested in the names, right? In the people, right? Okay. So I think with this we can play a little bit, right? Okay. So I'm going to click view to see. Okay. So here, for example, I can search and I should be there, right? I'm not there. This is strange. Let me see what happened to my. Yes. I'm just trying to find the rows that represent my case, right? To be able to compare. Where? Yeah, it's there for sure. Okay. Oh, I think I know what it is. It's there is a setting So this is why it's important that I do it with you. There is a setting in this filter that restricts how many values it has, I think, if I recall correctly. Well, but it has a lot. It should be there. No, I know. Because this, I didn't select this, the right one. Okay. That's the reason. Okay. So in this one now, I should be, right? Yes, I'm there, right? So if you click on me, you'll see. This table is wrongly formatted. This has to be average. This has to be average. And this has to be average. See? So here you see the difference, right? So my two cases, and you can see that I have two cases, right? My two cases, the number of unique days that they had events was only 6, right? While for these attorneys that are marked in the index, that number is 140, right? So this means that in this appellate, sorry, no, the number is like 20. Let me see. Let me remove that filter. Let me copy the widget. Do that. Right. Yes. So you see, I'm concentrating on these metrics, right? This is number of cases, number of days open, right? And number of unique days with events. Those three metrics. So if you look at the attorneys, right? These numbers are very high, right? 100. So at the medium, these cases are open almost 5 months, 6 months. But my cases, right? If you look me up, right? My numbers look very different, right? Because they get dismissed procedurally very quickly, right? Because they don't want to give me a hearing. And the difference is that I'm not marked in the index, right? That's the difference. If I was marked in the index, then it would be different. But I'm showing you this because with this you can debug these things. And for example, right, like if we look at that person that we saw before, Chris Branson, right? So that's party, but he's not a party. He is a representative, right? So we're going to add a field for representative. So we're going to restrict this, and we're going to say Brandon, right? What is his name? Chris Branson. Right? So his case are open for a long time. I mean, relative long time, right? 67 days at the median. But there's just a few numbers of days with unique events, like below the median, right? So there's not too much activity. This below the average, right? The activity in unique days, but the cases are open for 67 days, and it's interesting. So we can remove that. The other thing that is interesting here is the name markers, right? So, for example, if you look at the representatives, and in fact, let's look at it in the crypto payments page, right? Which is this, right? So this is crypto. This is let me see. Okay, we have to fix this because this table is should be this. So I need to fix all this to make it non-crypto, right, on the second page. Right, the logistical points. And then this would be espionage. Okay. So you have on the first page crypto, on the second page espionage, and in the third page you have the parties. These are not attorneys necessarily, right? But what I wanted to show you, if you go to crypto, right, there's something that is very strange here. If you look, so the name markers, right? So if you look at the representative and you look for something like king, which we know it's a prominence name marker, right? So there's one person that has it. If you look for hunt, or was it in the address that I saw it? No, in the parties. It's in one of these fields. I saw there's a lot of markers. Hunt, right? So you see hunt, right? And this is interesting because, for example, this filter you can change it to to use as metric the number of cases, for example, right? Or the record count, right? So if you look for hunt, which we know it's a name marker, right? So there's 2, 4, 6, right? So there's 6 representatives, 6 lawyers. This is an anomaly because there's only 90 lawyers, right? In this table, there were only 92, right? So how is it possible that almost 10%, or I don't know, something like 8%, have the name marker hunt, right? And they're marked in the index. It's not only because they have the name hunt, but I mean that on itself is an anomaly. But also, they are also marked in the index with crypto payments, right? The king, right? There's 2 that have the name king. I think Adams was the other name marker, right? Look, there's in terms of records, right? This has 3 records. So you have 1, 2, 3, 6, 7, 8, 9, 10, right? It's 12% of the sample of the representatives in this sample have the name Adams, and which also, it calls to question because the chief justice of this court, it has the name Adams, right? So I don't know, I don't know what are the rules on this, but if you are running a court and your name is Adams, and the representative or the party, and I'm just looking at the representative. If we do the same with the party or with the addresses, you will see that there's a lot of markers in there too. Like if you go to the crypto page, for example, right? And you look at the address and you search for hunt, sorry, Adams. Right. So there's one that has the marker Adams in the name of the street address. Wood is the other one, right? So look how many woods in the street, because wood is an important street name marker, right, in this network. So these are what this is these are the addresses of the lawyers that are marked in the index with crypto payments and are representatives before this first appellate court. Their streets have the wood marker with these proportions, right? And these are the number of cases that they have, right? So let's sum them up, right? So it's 9, 11, 12, 14, 15, 17, 18, 19, 20, 23, 25, 26, 27, 29, 30, 31, 32, 33, 34, 35, 37, 38, 39, 40, 43, 44, 46, 47. Imagine that. So in the street in the street names of the attorneys who are marked in the index, the name wood, right, is present, which is a name marker. We know that. I wrote about this in the book more than 5 months ago, right? About this specific marker. In fact, I think this marker is located in the glossary of the first volume of the book. I have a kind of an appendix in there that is kind of It's kind of an index of name markers, right? Of well-known markers, and wood and king are in there, and they appear in this data set like like it's nothing. So I guess beyond debugging this thing to death, what I wanted to show you is how powerful these technologies are and how easy they are to use, to the point that we started this demo maybe 2 hours ago, right from scratch. We didn't have anything, and in the space of 2 hours, we are at a point where we have dashboards, we can do searches, we can aggregate, we can produce maps, we can produce, and we can analyze this thing in different ways, right? But more than the analysis in itself, what I wanted to give you was the framework, right? And give you a repeatable process that you can take and reproduce and scale, and also vary and play with different other ideas and different metrics, right? Because these are the metrics that I came up with for this in this brief moment of time, right? But if we put our minds to this, we will be able to come with more sophisticated metrics. And the other thing I wanted to tell you is how powerful the aggregators are. I mean, for law enforcement, right? And for people that are not part of this network, because they're using the aggregators, right, to do these things against their targets. The problem they have now is that the aggregators expose them, right? Like, for example, the First Court of Appeals is an aggregator, obviously, and you can see that by the distribution of cases in a small group of attorneys, right, that are marked in the index with the crypto payments. So by having access to the data, that's what I did in this demo, right? Just using data from public sources that describe things that happen in this aggregator, in the First Court of Appeals, that is run by Chief Justice Adams. And just by doing that, you are able, with the data from the geo index of Elon Musk that Isidoro Cabello gave me, and then I made public, you can find these things yourself, right? So more than giving you the fish, I wanted to give you the fishing pole, right? Like how to fish, right? Like the technology, really. Right? So I think it is a good point to end this demo here. But I'm going to, of course, keep playing with this, and of course, there's other actions that I'm going to take with this group of players, right? Now, I want to say the only thing that, because like I can't keep doing this with all the other courts. Like I have no shortage of courts where I can do this same analysis, right, and send this to the IRS or to the FBI. Now, the problem I have is that I have all these cases in all these courts that my motions never get addressed, right? All I'm asking you, and I'm talking to the network, is to please address my motion. I'm not even asking for a particular ruling. The only thing I'm asking is please address the motions, right? Read the motions and make a decision on those motions. I have motions in the 387th that are pending, more than 40 motions. I have motions pending in other courts as well. Because like I will take other steps if my motions are not ruled on. For example, I could start contacting all the parties in these lawsuits, right, and telling them all about this. Because you can ignore my motions, but I'm guessing, right, if all these parties start complaining to the FBI or to, you cannot stop or filing motions for to set aside judgments, for example. You can't ignore the motions of 1,000 parties, right? I'm guessing, right? So the best way to avoid that from happening is to address my motions, because that way, I can move on from this. But as long as my motions are not addressed, I can't move on, right? And I will keep doing these demos, right? And taking action on this data. And I have no shortage of courts. I can do this with multiple courts, okay? So I'm going to stop this demo here. And I hope that my motions are addressed soon, right? And I'll see you on the next one. Good day.